Elasticity of demand represents the degree of responsiveness of a change in quantity as a result of a change in price. So in other words, you change the price a little bit and you observe what happens to quantity. The law of demand is still in effect. In other words, nothing about elasticity of demand negates the inverse relationship between P and Q. There are two ways to discuss elasticity. One is the total revenue method, and one is called the coefficient method. In terms of the total revenue method, total revenue is equal to sales price times quantity. So just like when you were a kid and you sold 10 glasses of lemonade, for 10 cents a piece, your total revenue was $1. And the same is true for big businesses too. That's how you get total revenue. So let's look at the total revenue method. So what we have is really 6 different combinations that could occur. So one thing that could happen is a business person could raise his price on an item and the total revenue might have fallen. That's really the same thing as saying this category right here, suppose you reduced the price and total revenue went up. We're going to call that thing elastic because what it means is that there has been a big responsiveness, a big response to the change in price. So here's another option that could occur. Possibility number 2. So a business person raised his price on an item and total revenue went up. And that's really the same statement as saying that if you lower the price, total revenue goes down. So we're going to give that name, the name inelastic. In other words, there hasn't been much responsiveness, or there hasn't been much sensitivity to a change in price. Then the third possibility is a business person manipulates the price up and down and it doesn't really make any difference because total revenue stays about the same. And we call that unit elasticity or either unitary elasticity. So that's the total revenue method. 6 different possibilities, but really just 3 groupings because each one is really this. When we talk about this category right here, it's actually one category. So now let's look at the coefficient method. Here's the coefficient, the formula for the coefficient. It says the percent change in Q divided by the percent change in P. And so don't get too hung up on the mathematics here. Let's say, for example, that we had a 5% change in price, and in one instance we had a 10% decline in quantity. Well, 10% would be the numerator, so 10's up here, and then the 5% change in price, so 10 divided by 5 gives you a coefficient of 2.0, which, as we'll see in a minute, makes it elastic. Suppose we had the same 5% change in price down here, but this time we only had a 1% decline in quantity. So then we would have 1 divided by 5, or a coefficient of 0.2. So let's go to the next scene. So what we can say is if the elasticity of demand is greater than 1, then it is elastic. If it's less than 1, then it's inelastic. And if it's equal to 1, it's unitary. So now when we're saying this elastic region here, we're saying a little bit of change in price causes a big change in quantity. And it can be a big change either up or down depending on which way the price moved. And remember, when the quantity changes, it's going to change total revenue. When we're talking about an inelastic demand, we change a little bit in price, but it doesn't change the quantity too much. And in the unitary situation, it hardly makes a difference. So in terms of determinants of elasticity, we can say that whether it's a necessity or a luxury is important, how many substitutes available, and what is the price of the item relative to the income. So let's talk about the first one here. Luxury items would be something like a vacation or a fur coat or first-class airline travel or a new car. A necessity, your book says things like a hairbrush and a toothpaste would be a type of necessity. Other types would be bread and gasoline. And of course the state always they apply something called sin taxes to alcohol and cigarettes, not because they think it's sinful so much as they know that that alcohol and cigarettes are extremely inelastic. And so if you apply a tax to it, they know that the tax will be carried forward to you and I as the consumer. In terms of the availability of substitutes, think about coffee. That was the example the book used with a coefficient, I think, of 0.2. So there's not many substitutes for coffee. And you want to think of substitutes in a very broad way. So, for example, if the price of gasoline went up, which gasoline, would be a necessity and would be inelastic, there are still things you can substitute. You can get a motorcycle, you could carpool, you could move closer to your work, you could bicycle, you could reduce your Sunday outings. So there's, you have to think of substitutes in a very broad way. The same thing is true in terms of any product. Suppose you say, well, I like Coors. But there's also Budweiser and Miller and Pabst and Michelob, and then there's also wine and liquor as a substitute. So the general principle is the more substitutes there are, the bigger the elasticity. This third item here, the price relative to the income, well, when you make a decision to buy a piece of bubble gum as opposed to the decision to buy a car, obviously the car is going to get more attention. And so the principle there is that the higher the price is relative to the income, the higher the elasticity. Here's one item we need to make sure of. Slope and elasticity are not the same thing. Elasticity deals with a percent change, whereas slope deals with an absolute change. So we know that the slope of a straight line is equal to rise over run. And in this example here, it rises from A to B, and it runs from B to C, so the slope is equal to AB over BC. And now let's go to a normal demand curve. So what you see is that a normal straight line demand curve includes a region that is elastic as well as including a region that is inelastic. And we know that the slope of a straight line is constant throughout, so that signifies that slope and elasticity must be different. So now let's go to figure 4.5. It is helpful for understanding. Okay, here's figure 4.5. So if we're at point F right here, we see that the price is 25 cents, and we see that at 25 cents there'll be a quantity of 12 units sold. So 25 times 12 gives you $3. And then when we move from point F to point G, the price is now 20 cents, but we've picked up 4 extra units. In other words, we've gone from 12 units to 16 units. So 20 cents times 16 units gives us $3.20. And so when we move from point F to point G, we went from $3 to $3.20. So as price went down, total revenue went up. So we know that this must be in the elastic region. And let me add one other point here. So at point F at 25 cents, we end up losing the 5 cents here. The difference between 25 and 20 cents is 5 cents, and we have 12 units. So 12 times 5 is 60 cents. So we're losing 60 cents. But in the process, look what we're doing. We at point G, we've got 20 cents, and we're selling 16 items. So that 20 cents, the extra 4 items here times 20 cents is a plus 80 cents. When we take the plus 80 and add the negative 60 cents, we come out ahead 20 cents. And that conforms with what we just found out, because we know when we went from point F to point G, we went from $3 to $3.20. So all we're saying right here really is that this rectangle is 20 cents bigger than this rectangle right here at point F. So just hope that kind of makes sense for you. So what we just proved was that elasticity is not the same thing as slope. It gets a little bit confusing though, because in this last slide here we do have some extreme examples, what we might call perfect inelasticity. So suppose you're a diabetic and you need some insulin. Well, you're not going to negotiate on price. You need the insulin. Whatever the quantity is down here, it's a necessity for you, so you'll pay whatever you have to. So in this case, price is determined from the supply side. So here's a supply curve coming. If there's a lot of competition, maybe it's down here. If only 1 or 2 pharmaceuticals do it, maybe the supply curve is up here. In this other example, perfect elasticity, we'll see that a lot when we get into pure competition. For the time being, let's just say if there's a change in price here, just a penny, it is so responsive, it is so sensitive that the quantity falls off to zero, and that's called perfect elasticity. So elasticity of demand is a neat concept. It helps to explain a lot of consumer behavior. I suppose in the Hampton Roads area, one great big experiment we will see in the next few years are the tolls on the tunnel. So in other words, the price of using the tolls will go up, and there will be a response and a sensitivity to that, and we'll see what happens.